Okay, so let's start with the really exciting topic, mobile development. It's basically building apps that run on phones and tablets. Think Instagram, TikTok, or even banking apps. There are actually a few different ways to do it. First, you can go the native route, which means writing code specifically for either iOS using Swift or Objective-C, or for Android with Java or Kotlin. This gives you really great performance and lets you directly access all the features of the device. Then there's cross-platform development tools like React Native, Flutter, or Xamarin let you write your code once and have it run on both iOS and Android, which can save a lot of time and effort. And finally, hybrid development combines web technologies like HTML, CSS, and JavaScript within a native container, often using frameworks like Cordova or Ionic. It's really good for quickly getting an app out the door, but sometimes performance might not be quite as snappy. Okay, let's talk about how mobile apps are actually built. There are a few main ways developers approach this. We have native development, hybrid development, and cross-platform. Native means building an app specifically for one platform like iOS or Android using the native languages. That gives you the best performance and access to everything the device offers, but it's also more expensive because you need separate code bases for each platform. Then we have hybrid development. This uses web technologies like HTML, CSS, and JavaScript, wrapped up in a native container. It's faster and cheaper than native because you can reuse some of your code across platforms, but performance might not be quite as good. Finally, there's cross-platform development, which allows you to build one app that runs on both iOS and Android from a single code base, offering great efficiency. The best choice really depends on what you're trying to achieve with the app. Okay, so let's kick off our exploration of iOS development. The first thing you'll want to get familiar with is Swift. It's Apple's go-to language for building apps. Alongside that, you absolutely need Xcode. It's like your supercharged workshop where you write and test your code. Then there's Cocoa Touch, the framework that gives you all the tools to design how your app looks and feels. And a big part of iOS development is visually designing your user interface using storyboards. Think of them as blueprints for your app screens. Finally, auto layout will help ensure everything looks great on different iPhones and iPads. Okay, so we're starting with the basics of Android development. First off, you'll need the Android SDK. It's like a toolbox full of everything you need. Then there are the programming languages. Most developers use Java, but Google is really pushing Kotlin now, which is a fantastic option too. Next up is XML, and that's how we design the look and feel of our apps. Finally, Gradle is the build system. It takes all your code and resources and turns them into a working app. Okay, let's jump into React Native. Basically, it's a way to create mobile apps for both iPhones and Android phones using JavaScript and the familiar React library. If you already know React from web development, you'll pick this up really fast. The core idea is that we build our app using components, kind of like Lego bricks. JSX helps us write the UI in a way that's similar to HTML, making it much easier to design and visualize what we want. We also deal with state, which is essentially how your app keeps track of information and updates when things change. And finally, you'll learn about lifecycle methods or hooks now that help manage the component's behavior. Okay, let's kick things off with Flutter. It's a really exciting toolkit for building apps across different platforms from mobile to web. The core idea is that you build your user interface using widgets. Think of them as the individual components that make up your app screen. A super cool feature is hot reload, which means you can see changes in your code instantly without having to completely rebuild and restart your app. Flutter uses a declarative approach, so instead of telling it **** to build things, you just describe *** what *** you want the UI to look like, and Flutter takes care of the actual rendering. Okay, let's talk about Xamarin. Think of it as a way to build mobile apps using C#, basically bringing the power of the Init world to iOS and Android. There are two main ways you can use Xamarin. Forms allows you to share most of your code between platforms, which is great for quickly building similar apps. And then there's Xamarin Native, which lets you build truly native apps, giving you full access to all the platform-specific features and capabilities. The big advantage here is that you can use a single codebase, saving time and money while still delivering fantastic results. Okay, let's talk about Kotlin. It's quickly becoming the go-to language for building apps on Android. Basically, it's a newer version of Java that makes things much easier and safer. You'll find it's significantly more concise, meaning you write less code to achieve the same result. Plus, it has built-in features to help prevent those frustrating crashes caused by null pointer exceptions. And best of all, Kotlin plays really well with existing Java code, so you don't have to rewrite everything from scratch. Okay, so let's talk about Swift. It's the language we'll be using to build iOS apps. It's a really fantastic choice for mobile development. Swift was designed with modern practices in mind, making it safer and faster than previous languages like Objective-C. Plus, it's surprisingly easy to pick up, even if you're new to programming. It's incredibly fast on iPhones and iPads, and there's a huge community ready to help you out, so plenty of resources available. Basically, it's the go-to language for creating amazing iOS experiences. Okay, let's talk about Java. It's the main language used for building Android apps. You'll need a good grasp of some core programming principles like object-oriented programming, which is all about organizing your code into reusable classes and objects. Don't worry if that sounds intimidating, we'll break it down. We'll also cover things like data types, the different kinds of information your app will handle, and how to control the flow of execution using if statements, loops, and other tools. Java provides a solid foundation for building robust and scalable Android applications. Okay, so let's talk about Dart. It's the language that makes Flutter tick, and it's pretty awesome if you're getting into mobile development. Think of it as a modern, really smart way to write code for your apps. It has some cool features like strong typing, which helps catch errors before they become problems, and null safety, which is fantastic for building more stable apps. Plus, Dart's got this amazing hot reload feature that lets you see changes instantly without restarting the app, making development a breeze. Let's look at a super simple example of how it works, just a little hello Flutter program to get us started. Okay, let's talk about how mobile apps are built from the inside out. We often think of a mobile app as just what we see, the beautiful UI, but there's actually a lot happening behind the scenes. It's built using layers like a layered cake. First, you have the presentation layer, which is everything the user interacts with: buttons, screens, and all that good stuff. Then comes the business logic layer. This is where the app does things. It processes data, makes decisions, and handles all sorts of operations. Finally, there's the data access layer, which deals with getting information from databases or API. There are different architectural patterns you can use to build these layers, like MVC or MVVM. Each has its own strengths, so choose one that fits your project's needs. Let's dive into how we structure mobile apps, the building blocks of their design. First, we have MVC, or Model View Controller. Think of it like this: your data is in a model, the visual display is in the view, and the controller acts as a traffic cop, handling user interactions and updating everything accordingly. It's straightforward, but can get messy as apps grow bigger. Next up is MVVM, Model View Model. This adds another layer, the view model, which sits between the model and the view. It exposes data and commands, making it easier to test your UI. Finally, we have Clean Architecture. This is all about keeping things organized and independent. It separates the core business rules from things like databases or UI frameworks. Imagine layers like entities, use cases, adapters, and infrastructure, each with a specific job. This approach leads to more maintainable code and makes it easier to adapt your app as needs change. Okay, let's talk about how a mobile app actually becomes an app available for people to use. It's not just writing code, there's a whole process involved. First, you start with an idea and plan what your app will do. Then comes the design phase, where you create visual sketches and mockups to figure out how it should look and function. The actual coding happens in two main environments: Android, typically using Java or Kotlin, and iOS, usually Swift or Objective-C. After development, thorough testing is crucial. You want to make sure everything works smoothly across different devices and operating systems. Finally, you release your app on the Google Play Store for Android users and the Apple App Store for iOS users. And it doesn't stop there. You'll need to continuously maintain your app with bug fixes, new features, and updates to keep it compatible as both operating systems evolve. Let's talk about how activities and fragments live their lives in Android apps. Think of an activity as a screen. When it's created, it sets up everything needed to show that screen. Then it gets started, becomes visible, and might pause if another screen pops up. Eventually, it stops, and then is destroyed when you close the app. Now, fragments are like smaller pieces of screens you can add and remove easily. They share their life cycle with the activity they are attached to, but also have their own stages: attached, active, paused, detached, and destroyed. Using these life cycles effectively allows you to create apps that respond smoothly to user interactions and changes. Okay, let's dive into how a view controller behaves throughout its lifetime within an iOS app. Think of it like a journey. It starts with initialization, then loads all its data, becomes visible, and finally disappears. We have 6 main stages. Initialization, where the controller is created. View did load to set up things like labels and buttons after the view has loaded. View will appear when the screen's about to appear. View did appear once it's actually on the screen. View will disappear just before it disappears. And finally, view did disappear after it's gone. Each of these methods gets called at a specific time in this loop. It's super important to understand this flow because it directly impacts how your app responds to user actions and changes. Okay, let's talk about getting users around your mobile app, specifically navigation. Think of it like the roadmap for your app. We have things like a navigation bar at the top to quickly jump between main sections, or tabs that let you switch between related views. Frameworks often use routing libraries to handle these transitions smoothly. Different approaches, like push and pop navigation, determine how screens are added and removed from the user's view. A well-designed navigation system keeps users engaged and makes it easy for them to find what they're looking for. Okay, let's dive into state management. Basically, it's all about how your mobile app keeps track of information, things like user settings or what's currently displayed. Without a good system for managing this data, you can end up with a confusing and frustrating experience for users. You might see the same screen behaving differently at different times, which is a big no-no. There are several ways to handle this, from simple local storage options like saving preferences to more robust architectures like Redux or React Context. The best choice really depends on how big and complicated your app is. Okay, let's talk about managing data in your React Native apps. As things get more complex, and they definitely will, you'll realize you need a way to keep track of all the different pieces of information that might be happening throughout your application. Traditionally, passing data down through every single component was a real pain. That's where Redux and the Context API come in handy. Redux is like having a central hub for called the state in your app. It's a single source of truth. It has a really specific way that changes happen, which makes debugging much easier. And then we have the Context API, which is great for simpler situations where you just need to share data between components without constantly passing props around. Okay, let's talk about managing data in Flutter apps. We're going to look at 3 main ways to handle state. First up is Provider. It's really easy to use and relies on a simple idea of passing data down through your widgets. Then there's RiverPod, which builds upon Provider and makes things more reliable for testing. Finally, we have BelowC. This is a bigger pattern that helps keep your code organized and separates the logic from what actually displays on the screen. Okay, let's talk about storing data locally on mobile devices. It's super important for apps that need to work offline or offer a better user experience by caching information. We have a few great options here. First up is SQLite. It's like a mini database built right into your app and known for being really reliable. Then there's Core Data, which is Apple's way of making things a bit easier on iOS, and Room Persistence Library, which does something similar but specifically designed for Android development. Each one has its own advantages. SQLite is super simple, core data provides more structure, and Room makes working with SQLite on Android much smoother. Think about what your app needs when deciding which one to use. Let's talk about keeping your mobile app's database running smoothly. A slow database can really frustrate users, so optimization is key. We'll cover a few crucial strategies. First, make sure you're writing efficient queries, think indexes, and avoiding pulling in the data at once. Then, regularly clean up old or unused data to keep your database size manageable. Caching frequently accessed information on the client side can also significantly boost performance. Finally, proper database design, like making sure you're storing only what you need and using appropriate data types, plays a huge role. For mobile development, lightweight databases like SQLite or Realm are often fantastic choices because they're built for efficiency on smaller devices. Okay, let's talk about integrating RESTful API into our mobile apps. Basically, these API are like the rules of communication between your app and a server in the cloud. We're using something called REST. It's an architectural style that makes things really clear how to interact with resources and the server. Think of HTTP methods like get, post, put, and delete as the verbs you use to request information or make changes. And just for example, look at this JavaScript code snippet. It shows a simple post request using fetch to create a new user. It's important to handle potential errors and always consider security best practices when dealing with API. Okay, let's talk about how GraphQL can really level up your mobile apps. For a long time, we've been using REST API, which can sometimes be a bit clunky, sending too much data or needing to make multiple requests to get everything you want. GraphQL changes that game completely. Instead of having fixed endpoints, it gives the app more control over exactly what data is needed. Think of it as asking for only the ingredients you need from a kitchen, instead of getting a whole meal delivered when you just wanted a salad. This means fewer network requests, faster loading times, and generally a smoother experience for your users. Plus, it's easier to manage your backend. Okay, so when we're building mobile apps, we often get data from Web API, and that data is frequently in JSON format. Parsing is how our app turns that plain text into something it can actually use asterisk. It's like taking a recipe written in another language and figuring out exactly what ingredients and steps you need to follow. We'll look at some common libraries, like JavaScript's built in JSON parse, which is super simple and quick, or Jackson for Java projects if you're building with that. And don't forget about JSON, a great option specifically designed for Android. So, understanding these different approaches can really make your development process smoother. Let's talk about keeping your mobile app secure. We'll explore 3 key methods for authentication: OAuth, JWT, and Firebase Auth. OAuth lets users sign in with existing accounts like Google or Facebook, no need to create a new password. JWT are like digital keys that securely transmit user information between the app and the server. And Firebase Auth is a really handy service from Google that simplifies all of this for you, handling things like email logins and social sign-in. Okay, let's talk about keeping your app's sensitive data safe. When you're storing things like API keys or user passwords and shared preferences which are easy to access, that can be a major security risk. Luckily, mobile platforms offer better options. On iOS and newer Android devices, you can use the Keychain service. This is essentially a secure vault for your secrets. It uses strong encryption, making it really difficult for anyone to steal data from the device. Android has a similar feature called Encrypted Shared Preferences, which leverages the key store to manage these keys securely. Think of it as adding an extra layer of protection, hardware-backed security when possible. This significantly reduces the chances of your app's secrets getting exposed, so always prioritize these secure storage methods. Okay, let's talk about push notifications. They're a really important part of building engaging mobile apps. Basically, they're how you can send instant updates to your users without them having to open the app itself. We have 2 main systems here: Firebase Cloud Messaging, or FCM, which is Google's solution that works on Android, and Apple Push Notification Service, or Appens, which handles iOS devices. FCM acts as a sort of intermediary, making it easier for you to send notifications to both platforms. Think of it like this: your app tells FCM what it wants to say, and then FCM figures out how to get the message delivered directly to the user's phone, using APN for Apple devices. Okay, so when we're talking about mobile development, it's really important to understand how apps keep working even when you're not actively using them. That's where background services come in. They're like the unsung heroes of your app, quietly handling things behind the scenes. Think about syncing your data automatically with a server, or constantly tracking your location with permission, naturally. These services are designed to run continuously and do more complex tasks than simple one-off tasks which just finish up quickly after being triggered. It's really all about keeping your app responsive and doing what it needs to do without needing constant user interaction. Okay, let's talk about adding location and maps to your mobile apps. It's a really powerful feature that can open up a lot of possibilities. Essentially, we're giving our apps the ability to know where the user is or understand an address. We'll cover how to get access to the device's location using built-in API on both Android and iOS, and then look at some popular map SDK like Google Maps and Apple Map Kit that help us display those locations on a map for our users. Okay, let's talk about device permissions. They are seriously important for any mobile developer. Basically, permissions are how your app talks to the phone's resources like its location or camera. It's all about respecting the user and making sure you only get access to what you genuinely need. We have runtime permissions which are asked at the moment you need them, and system-level permissions which require a manual setting change in the device's settings. The key is to be upfront with users. Explain why your app needs each permission. And if they say no, you need to handle it gracefully by offering an alternative or just letting them know why it's important. Finally, keep your permissions list up to date as things change. Okay, let's talk about bringing cameras and media into our mobile apps. First up, you'll need to access the device's camera. Android developers often use CameraX or the CameraTour API, while iOS utilizes a vFoundation. Then, when it comes to working with media files like videos and images, you can handle playback and recording using libraries like XOPlayer on Android, ensuring you always get user permission before accessing sensitive resources. Okay, let's dive into offline data sync. Basically, it means your app can still function and even provide some value to the user even when they don't have an internet connection. It all starts with storing data locally on the device. Think of it like a mini database. When the phone regains connectivity, the app then compares that local data with what's in the server, resolving any differences. There are different ways to handle those differences, from simply using the most recent change last write wins to asking the user directly if they want to merge the changes. It's important to validate your data thoroughly and use SWOT caching strategies to keep things running smoothly. Okay, let's talk about handling files in your mobile app, specifically uploads and downloads. These are really important for things like photo sharing, document editing, or even just downloading content from a server. On the client side, you'll use tools like Fetch or XML HTTP request to start sending files. But remember, the server needs to be ready too. It's your job to validate what the user is uploading and make sure it gets stored securely, often using something like cloud storage. And don't forget to give the user some feedback on how the upload is progressing. A progress bar can go a long way. For downloads, the server needs to generate unique URL for each file, which makes serving them much more efficient. You'll use Fetch or XML HTTP request again on the client side, and caching your downloaded files can significantly speed things up. Okay, let's talk about something really important for mobile apps: how to handle network errors. It's super common for users to lose their internet connection or have slow speeds, and that can totally throw off your app. We need to anticipate these problems and build in ways to deal with them gracefully. First, there are a few common types of network errors, things like timeouts, no internet at all, or server issues. Each one needs a different response. We'll cover some key strategies, including prioritizing essential features, using retry mechanisms that don't just spam the request, giving users clear feedback about what's happening, and even allowing your app to work offline when possible by caching data locally. Basically, good error handling makes your app more reliable and user-friendly. Okay, let's talk about making your mobile apps and websites look good on every device. That's where responsive design comes in. It's all about adapting to the screen, whether it's a tiny phone or a huge tablet. The key is using flexible grids, which means sizing elements with percentages rather than fixed numbers. And then, you can use media queries to apply different styles depending on the screen size. Think of it as saying, if this screen is small, show me this, if it's big, show me that. It's a really important part of mobile development. Okay, let's talk about how to make your apps look amazing on every device. The biggest challenge is that phones come in all shapes and sizes. Instead of trying to create a single design that works perfectly for one screen, we use something called adaptive layouts. We do this primarily through CSS media queries, basically telling the browser if the screen size, apply these styles. And we make sure our designs are flexible using things like Flexbox and Grid, so elements can shift around automatically to fit the space available. Using relative units for sizing is also key. It lets your design scale nicely across different devices. Okay, so let's talk about adding some flair to your mobile app, specifically animations and transitions. These aren't just fancy effects, they really improve how users experience your app. Basically, animations are like visual feedback when something happens, and transitions help smoothly guide the user between different screens or elements. Android uses the Animator API and View Property Animator, while iOS leans on UI View Animation and Core Animation. A simple example is a button tap animation, maybe a slight scale and color change, but you can get really creative. The key takeaway is that adding these small details can make a huge difference in how polished and engaging your app feels. Let's talk about making your mobile app run like a dream. Performance is everything. Users expect things to load quickly and feel responsive. The first step is figuring out where the bottlenecks are, using tools to see what's slowing things down. Then we can focus on writing efficient code, optimizing images, minimizing network requests, and carefully managing background tasks. It's an ongoing process of testing and tweaking to make sure your app feels snappy and keeps users happy. Okay, let's talk about making our mobile apps lightning fast. We're going to dive into lazy loading and how it's a key part of smart asset management. Basically, large images and videos can really slow down your app's initial load time, which is something we want to avoid at all costs. Lazy loading means we only load those non-essential resources like pictures or video clips when the user actually needs them or when they're about to come into view. It's a fantastic way to reduce the initial download size and make your app feel much more responsive. And speaking of assets, good asset management is crucial. This includes compressing images, making sure you're serving different sizes based on the device screen, and even breaking up your JavaScript code into smaller pieces. By being strategic about how we handle our resources, we can create a smoother, faster experience for our users. Okay, let's talk about keeping your mobile apps running smoothly and not draining the user's phone battery. Battery and resource management is huge deal. Users really appreciate when an app doesn't hog all their device power. We want to make sure our apps are efficient. A big part of this involves being smart about background tasks, minimizing what happens automatically in the background. Then think about this: network requests fewer and smaller ones mean less battery drain. Also, be mindful of how you update your user interface. Batching updates together can help a lot. Finally, remember to release resources when they are no longer needed, and watch out for memory leaks. Android has tools to help pinpoint power-hungry parts of your app, and iOS offers its own strategies with core data and monitoring the app's lifecycle. Okay, let's talk about mobile app testing. It's super important. It's not just about seeing if the app works but really simulating how people will actually use it. We have different kinds of tests, like unit tests, which look at individual parts of the code, and integration tests to see how those parts work together. Then there's UI testing, both manually and with automated tools, which ensures everything looks good and works smoothly when a user interacts with it. Functional tests verify all features are doing what they're supposed to, and performance tests check that the app is fast and reliable. And don't forget about testing on different devices. There's a massive range out there, so you need to make sure your app looks and feels great on everything from small phones to tablets. You can use emulators or real device labs, and even cloud-based services can help you scale your tests. Okay, let's talk about unit testing. It's a super important skill for any mobile developer. Basically, it means testing small pieces of your code, like functions or methods, in isolation. This helps you catch bugs early and make sure everything works as expected before you put it all together. We have a few popular frameworks to choose from: JUnit for Android, XCTest for iOS, and Mockito is great for Java and Kotlin, particularly useful when dealing with external dependencies. Think of mocking it as creating fake versions of things your code needs so you can test without actually needing those real components. And don't forget about test-driven development. It's a fantastic way to build apps that are naturally easier to test. Let's talk about UI testing. It's a really important part of building robust mobile apps. Basically, you want to make sure your app looks and works the same way on all devices and screen sizes. We've got a few different frameworks we can use for this. Espresso is Google's framework specifically for Android apps. It plays nicely with XCTest. Then there's XCTest UI, Apple's native iOS testing tool. And finally, Detox is great because it lets you test your app on both Android and iOS from a single set of tests, simulating how real users would actually interact with the app. Let's talk about end-to-end testing for mobile apps, specifically using Appium. Appium is a really cool tool that lets you simulate how users actually interact with your app, clicking buttons, typing in fields, navigating screens, and so on. It essentially acts as the middleman between your test code and the device itself, whether it's an actual smartphone or a simulator. It's super useful because it gives you confidence that everything is working smoothly from start to finish across both iOS and Android platforms. Okay, let's talk about CI/CD in the context of mobile development. It's basically about automating how we build, test, and release our apps. Think of it as a streamlined pipeline. The continuous integration part ensures that all those code changes are constantly being combined and automatically built, with tests running behind the scenes to catch any problems early on. Then there's continuous testing, which goes even further by automating various kinds of tests, like making sure the user interface works correctly or checking how well your app performs. Finally, continuous delivery takes that tested code and automates the process of getting it into different environments like a staging area before going live to users. The goal is to get updates out faster, with higher quality, and with less chance of things breaking. Okay, so after all that development, it's time to get your app out into the world. Let's talk about getting it onto the App Store and Google Play. First, you need to prepare everything. Make sure you have high quality screenshots, a compelling description, and all the keywords you can think of. For iOS, you'll use App Store Connect for uploading your app binary and metadata, which involves a review process that can take anywhere from 1 to 7 days. And for Android, you'll upload it through the Google Play console, with different release tracks like alpha or beta to help manage the rollout. It's a pretty involved process, but getting it right is key to success. Okay, let's talk about keeping your mobile apps running smoothly and delivering updates effectively. A big part of that is versioning and release management. We'll start with using tools like Git to track all the changes you make to your app's code. It's like having a super detailed history book. Then, we need a system for assigning versions to each update. Something like semantic versioning can be really helpful here, letting you clearly communicate the type of changes in each release. Finally, think about releasing your app in stages, starting with internal testing, moving to a staging environment for more thorough checks, and then finally launching it live for everyone. Okay, let's talk about dealing with those pesky crashes. Every mobile developer knows they are inevitable. To keep your users happy and your app stable, we need to track these issues effectively. Firebase Crashlytics is a fantastic free tool from Google that automatically collects data when an app crashes. Think device logs, where the crash happened, and who was using it at the time. It's super easy to set up. Then there is Sentry, which is another powerful error tracking platform. Sentry is really good for capturing more than just crashes. You can track performance issues and even gather user feedback. It's a bit more flexible than Crashlytics, letting you customize what you're looking at. Often the best approach is to use both Crashlytics for quick crash detection and Sentry for deeper analysis and proactive monitoring. Okay, let's talk about incorporating user feedback into your mobile development. This is really important because ultimately, you want an app that people actually love and find useful. It's not enough just to build something cool. You need to know what users are saying, and more importantly, act on it. So how do you do that? Well, start by keeping a close eye on the App Store's Google Play and Apple App Store. Reading reviews and ratings is key. Then consider adding an app surveys to get targeted feedback about specific areas of your app. Beta testing with a small group before a full launch can also catch issues early. And don't forget analytics. Tools like Firebase can tell you where users are getting stuck or what features they're using most often. Finally, make it easy for users to submit their own suggestions directly within the app via feedback forms. Negative reviews. Treat them as gold. They highlight areas that need improvement and show you how to build better relationships with your users. Okay, let's talk about how to make money with your mobile app, specifically through in-app purchases and subscriptions. IAP are like buying individual items or boost asterisk with an asterisk the app itself. Think of it like buying coins in a game or unlocking special features. There are different types of IAP, some you use up, others that say yours forever. Then we have subscriptions, which are recurring payments for ongoing access to content or premium features. Think of Netflix, you pay monthly to keep accessing the shows and movies. Both require careful planning around pricing, what's being offered, and making sure users feel they're getting good value. Okay, let's talk about bringing in some revenue through ads. We'll look at two popular options, AdMob from Google and Facebook's Audience Network. Both are great ways to earn money from your app, but they work slightly differently. With AdMob, you basically create an account, connect it to your existing AdSense account, and then request different types of ads like banners or interstitials from Google. Then you integrate the AdMob SDK into your code to actually display those ads. Facebook Audience Network is a little more involved. You'll need a Business Manager account, register your app with Facebook, and then use their SDK to serve targeted ads based on user interests. It's worth noting that AdMob can be easier to get started with quickly, while FAN offers better targeting options, so think about what works best for your asterisk app. Okay, so let's talk about how we bring web development into mobile apps. A web view is like a tiny browser tucked right inside your app. It lets you display HTML, CSS, and JavaScript just like you would on any website. Now, hybrid app frameworks like React Native or Flutter use web views as a core part of their approach. Instead of writing entirely native code, you write in languages like JavaScript or Dart, and the framework compiles it into an actual mobile app. It's really clever because the UI is mostly built using web view components, which makes things much easier if you already know web development. Okay, let's dive into Bluetooth and NFC, both really important for mobile developers. Bluetooth is great for connecting devices like headphones or keyboards over a reasonable distance, using standardized profiles to make everything work smoothly. Think about sharing audio or controlling your device with a connected keyboard. Then there's NFC, which operates at an incredibly short range, basically just bringing two phones together. It's super convenient for things like mobile payments and quickly pairing devices. Okay, let's talk about real-time communication, how your mobile apps can chat with each other instantly. We'll start with sockets. Think of a socket like a dedicated phone line that keeps an open connection between two devices for continuous data exchange. WebRTC takes this a step further, providing true real-time communication directly between users' browsers or mobile apps. It builds on sockets to achieve low latency, meaning almost no delay, and operates peer-to-peer, which reduces the need for heavy server processing. It handles all the complicated bits like encryption automatically, making it incredibly powerful and easy to use. Okay, let's talk about making your mobile apps accessible to everyone. It's really important to consider accessibility from the start. It's not just a bonus feature. We want to make sure people using screen readers can easily navigate your app, and that users with visual impairments can comfortably read text. Things like ensuring good color contrast, allowing users to adjust font sizes, and providing alternative text for images are all key. Don't forget captions for videos and transcripts for audio. These really help too. There are some fantastic resources out there to help you check your work, so be sure to use them. Okay, let's talk about keeping user data safe, a really important aspect of mobile development. Basically, GDPR and similar regulations mean you have to be super careful about how you collect, use, and protect personal information. Start by only asking for the bare minimum needed for your app to work. Be upfront with users about what you're collecting and why. Get their clear consent first. Then, make sure you're doing everything possible to secure that data with strong encryption and safe storage practices. And lastly, be ready to handle user requests like wanting to delete their information or access it, ensuring you have a system in place for those types of requests. Okay, let's talk about rate limiting and throttling. These are really important concepts for any mobile developer working with API. Think of them as guardians protecting your app and its backend. Rate limiting is like a strict rule. You can only make this many requests in a certain amount of time. If you go over, you're blocked. Throttling is a little more gentle. It slows things down gradually to prevent sudden spikes that could overload your server. Both are vital for preventing abuse, ensuring everyone gets a fair shot at using the API and keeping everything running smoothly. Okay, let's talk about integrating third-party SDK. Think of these as ready-made toolboxes packed with features that can supercharge your mobile app. We're talking things like payment processing, analytics to track user behavior, and even push notifications to keep users engaged. There are tons out there: Stripe for payments, Firebase Analytics for data insights, and so on. The main advantage is speed. You don't have to build these complicated systems yourself. However, it's really important to be aware of potential security risks and make sure the SDK is reliable before integrating it into your app. Okay, let's talk about keeping your mobile app secure. It's really important because users are trusting you with their personal information. First off, always protect sensitive data like passwords by using the device's built-in security features, things like Keychain on iOS and Keystore on Android. Also, make sure every connection to the server is encrypted using HTTPS. And don't forget to carefully check all input from users. That means validating it and cleaning it up properly to prevent issues. Finally, use strong authentication methods and keep an eye out for security audits and penetration tests to catch any potential problems. Okay, so now we're moving on to protecting our app's code. This step is all about obfuscation and a tool called ProGuard. Think of it like hiding your code, making it really tough for anyone to figure out how it works without proper knowledge. ProGuard is a powerful tool specifically designed for Android apps. It helps by removing unnecessary parts, optimizing performance, and most importantly, renaming everything so that the code doesn't give away any clues about its original purpose. Basically, it scrambles your code while still allowing the app to run perfectly. Let's talk about root and jailbreak detection. It's a really important part of building secure mobile apps. Basically, these techniques help us figure out if a device has been modified in ways that could compromise its security. Why do we care? Well, detecting rooted or jailbroken devices helps protect our users from malware, ensures they're getting the real version of our app, and can even be necessary for things like in-app purchases. There are several different ways to detect these modifications: looking at system calls on Android, checking file structures on iOS, and more. But keep in mind that attackers are always finding new ways around these defenses, so security needs to be a layered approach. Okay, let's dive into certificate pinning, a really cool security feature for mobile apps. Essentially, it's like giving your app a very specific password to recognize its server. Instead of just trusting the general certificate presented by the server, we hardcode the exact fingerprint of that certificate inside our app. This makes it incredibly difficult for someone to intercept traffic and swap out a fake certificate. They'd have to not only spoof the certificate but also know the precise fingerprint. It's like having an unbreakable lock on your connection, boosting user trust and protecting against potential attacks. Okay, so let's talk about getting users to the right place within your mobile app. That's where deep linking comes in. Essentially, a deep link is like giving your app a direct address. It's a URL that takes someone straight to a specific screen or piece of content inside your application. Now, traditionally, if you clicked on a link to an app, it would just open the app if it was already installed. If not, it'd send you to the App Store. Deep links are smarter. They open the app directly if it's there, otherwise they take you to the App Store. And when we're talking about iOS and Android, universal links are the way to go. They use HTTPS for security and provide a really consistent experience no matter if the user has your app or not, making things much smoother for them and boosting visibility in the App Store. Let's talk about backends for mobile apps. Your front end is what users see, but you need something to store data, manage users, and handle all the behind-the-scenes logic. Firebase is a really popular choice because it's super easy to get started with. It's like a pre-built backend. AWS Amplify integrates nicely with Amazon Web Services, which can be powerful for larger projects. And then there's PassServe. It's completely open source and gives you lots of control if you need something really customized. Okay, let's talk about making your mobile app truly global. That's where EI18 and IL10 come in. Internationalization is basically designing your app from the ground up to be adaptable. It means you build in flexibility so that when you want to add support for a new language or region, you don't have to completely rewrite everything. Localization is then taking those internationalized apps and actually adapting them for a specific locale, translating the text, making sure dates and numbers are displayed correctly, and considering cultural differences. It's really about providing the right experience for users around the world. A key part of this involves using resource files to store your translatable strings so you can easily manage and update translations. Okay, let's talk about design patterns in mobile development. These are like proven blueprints for how to structure your app's interface. They really help you build things efficiently and make sure users have a smooth experience. We've got some common ones: the navigation drawer, which is fantastic when you have a lot of options, the bottom navigation bar, great for quick access to core features, tab layouts, perfect for organizing related content, and floaty action buttons, those eye-catching buttons that highlight what users are most likely doing. It's important to think about how people will use your app, their flow through it, where they'll be using it, and of course sticking to the platform guidelines for iOS and Android. Okay, so let's talk about feature flags. They're like secret levers you can use in your mobile app development. Basically, they let you turn features on and off without needing to actually push out new code updates. It's a game changer for releasing quickly and safely. You define a flag, then use it in your code to control whether or not a feature is shown. And the really cool part? You manage those flags remotely, meaning you can change them on the fly without deploying anything. This means faster releases, /B testing to see what users love, targeted rollouts for different groups of people, and even emergency kill switches if something goes wrong. Think of it as having a remote control for your app's features. Okay, let's talk about how we tailor our mobile apps to different devices and operating systems. It's not enough to just build one version and hope it works everywhere. We use something called multi-flavored builds. Basically, this means creating separate versions of our app specifically designed for different combinations of things, like the OS version on a device, is it iOS or Android. What model is it? We create variants like debug for local testing, release for actual users, and then even more specific ones like iOS 15 or Android tablet with ARM64 architecture. This way, we can make sure the app runs perfectly well for everyone. Okay, so let's talk about how DevOps fits into the world of mobile development. Essentially, It's all about making the whole process from writing code to getting your app out there and keeping it running smoothly as efficient and reliable as possible. We're talking about automating things like building, testing, and deploying updates so you can get new features and bug fixes to users much faster. It also means thinking about how we manage the servers and infrastructure that support our apps. And because mobile apps run on a huge variety of devices, there are some specific challenges like ensuring your app works well across different screen sizes and operating system versions. We'll want to incorporate robust testing and monitoring tools to catch any problems early on. Okay, let's talk about logging in mobile apps. Logging is absolutely essential for any developer. It's like having a detailed record of what your app is doing. First, why do we log at all? It helps us find bugs, keep an eye on how the app performs, and really understand how users are interacting with it. The big thing to remember is that logging needs to be specific. Don't just say error, tell us exactly what went wrong, including the error message and where in your code it happened. We also want to use different levels of logging. Debug for when you're developing, info for general activity, warning for potential issues, error for serious problems, and fatal for things that could crash the app. Then, a really important practice is adding context. Include things like the user's ID or session information so we can easily track down what's happening. Finally, use a logging library to help you keep things organized and efficient. Okay, let's talk about version control and how Git fits into mobile development. Think of Git as your project's personal time machine. It lets you track every change made to your code, go back if something breaks, and work seamlessly with the team. Collaboration is huge in mobile, so Git makes that super easy. It also gives you a complete record of everything, which is really valuable for debugging or understanding how the codebase evolved. We'll cover some basic commands like cloning, staging changes, committing them with a message, and pushing those commits to a remote repository. Basically, it's your safety net and team coordination tool. Okay, so let's talk about making sure our mobile apps run smoothly and without hiccups. First up, debugging. That's all about figuring out why something isn't working the way it should. We use things like logging statements to see what's happening inside the code, breakpoints to pause execution and check values, and debugger tools within our development environments. And don't forget crash reporting services. They automatically collect information when your app crashes, making it much easier to fix problems. Now, let's move on to profiling. This is where we measure how efficiently our app is using resources like the CPU and memory. We can use CPU profiling to identify slow functions, memory profiling to find leaks, and network profiling to optimize data usage. Essentially, debugging finds what went wrong, while profiling helps us understand how efficiently things are running. Okay, let's dive into comparing some popular hybrid mobile frameworks. We've got React Native, Flutter, and Xamarin, each with their own strengths and weaknesses. React Native uses JavaScript and the familiar React library, so if you know React, getting started is a breeze. It has a huge community and lots of available components. However, it can sometimes require bridging between its JavaScript code and the native platform, which can make things tricky when building complex UI. Then there's Flutter, developed by Google. It's built with Dart, and is known for delivering really great performance and stunningly consistent UI across both iOS and Android. The hot reload feature is super speedy too. It's a bit newer than React Native, so the community isn't quite as massive yet. Finally, we have Xamarin, which uses CHash and the NET framework. This one's particularly good if you already know your way around Microsoft technologies. It allows you to share a huge chunk of code between iOS, Android, and even Windows apps. Keep in mind that Xamarin can sometimes be slower than native development, and apps tend to be a bit larger. Okay, so you've stumbled into a legacy mobile project. It happens. The first thing to do is get a good handle on what you're dealing with. Start by really understanding how the codebase is structured, the technologies used, and how information moves around. Static analysis tools can be super helpful for spotting potential problems and complexity. Then, don't try to rewrite everything at once. Instead, think about making small, targeted improvements over time. Update dependencies incrementally, add unit tests, and write clear documentation as you go. It's totally okay to not touch everything *. Focus on the areas that really matter, things impacting stability or performance. And for goodness sake, make sure you understand the version control history, it'll save you a ton of time later on. Okay, let's talk about prototyping tools. When you're starting out with mobile app development, it's super important to get a visual representation of what your app will look like and how users will interact with it. We have two really popular options, Figma and Adobe XD. Figma is fantastic for teams because it allows everyone to work together in real time on the same design, perfect for quick iterations and brainstorming. Adobe XD, on the other hand, is a dedicated UX/UI design tool that's part of the Adobe ecosystem, which makes sense if you're already using other Adobe products. Both have great features for creating interactive prototypes, so it really comes down to your team's workflow and preferences. Okay, let's talk about extending your mobile apps with native modules and plugins. These are fantastic ways to add custom features without rewriting everything from scratch. Native modules are essentially reusable code snippets. Think of them like mini libraries built specifically for iOS or Android. They're great for things you need to do repeatedly, keeping your main app cleaner. Then we have plugins, which are often third-party libraries that handle integrations with services like payment gateways or social media platforms. Using these tools can speed up development, make updates easier, and even boost performance by letting native code handle the heavier lifting. Okay, let's talk about analytics for mobile apps. Tracking how users actually use your app is incredibly important. It helps you see what's working, what's not, and ultimately make better decisions about the product. There are several different SDK out there. Firebase Analytics is a really popular choice because it's free and relatively easy to set up. Mixpanel excels at understanding user behavior and retention, while Amplitude is fantastic for tracking how your app drives product growth. Think about what you're trying to achieve with your app when choosing an analytics solution. Don't just collect data for the sake of collecting it, focus on the metrics that really matter. Okay, let's dive into how we can get that fresh, live information flowing to our mobile apps. Think about what it's like when you're checking a sports score or seeing real-time stock updates. That instant feedback is key. There are a few really popular ways to achieve this. WebSockets are fantastic because they create a constant connection, allowing both the app and server to send data back and forth seamlessly. Server-sent events, on the other hand, let the server push information to the app, which is often simpler for scenarios where you're mostly sending updates from the back end. And then there's lump polling. It's a bit older but still useful in certain situations. Okay, let's talk about how to welcome new users into your mobile app. The first thing you want to do is create a really strong onboarding experience. Think of it as your initial handshake. You'll typically start with a welcoming screen that quickly tells them what your app does and why they should care. Then highlight 2 or 3 key features that will make their lives easier. Don't just list them, show them in action. A really helpful thing to add is an interactive tutorial or walkthrough. These can guide users through the most important tasks with step-by-step instructions. And finally, keep a progress indicator so they know how far along they're in the process. Remember, people have short attention spans, so keep it brief and focus on what's truly important. Alright team, let's talk about how to actually earn some money with your mobile app. There are a bunch of different ways you can monetize. It's all about finding the right fit for your specific app and users. We've got the basics like in-app purchases where people buy things inside the app itself. Then there's advertising, banner ads, there's little interruptions, or even rewarded video ads that let users watch an ad to get something extra. Subscriptions are also popular, offering ongoing access for a fee. But it doesn't stop there. We have more sophisticated models like freemium, where you offer a basic version for free and charge for premium features. Affiliate marketing, when you promote other companies' products, or even sponsorships if you partner with brands to create some awesome content. Remember that user experience is super important. Don't bombard your users with ads. And always keep your long-term goals in mind as you build your monetization strategy. Okay, let's talk about how we can make our mobile apps even better by using dynamic links and referral systems. Dynamic links are like magic URL. They're not just static addresses, they change based on where the user is coming from. Think of them like a shortcut directly to specific content within your app, making it super easy for users to get what they need. They use the unique identifier for your app to know exactly where to send the user. Now, let's move on to referral programs. These are fantastic ways to encourage word-of-mouth marketing. You can reward users for bringing their friends on board with discounts, credits, or even tiered rewards based on how many people they refer. It's a win-win situation. You get new customers and your existing users feel valued. Let's talk about securing mobile apps with biometrics. More and more, we're seeing Face ID, fingerprint scanners, and even Ultra Touch ID systems being used. Basically, it's a way to make sure only the authorized user can get in. There are a few different types. Face ID on iPhones uses the camera to recognize your face, while Android and iOS devices typically use a fingerprint sensor. When you're building an app, remember that each platform has its own tools for integrating these features, so it's important to learn those specific API and always prioritize security by using device-safe storage. Okay, let's talk about how to share code when building for both iOS and Android. It's a really smart move to avoid rewriting everything from scratch. There are several frameworks that can help with this. React Native lets you use JavaScript to build truly native apps. It's super popular. Flutter is another great option, especially if you're looking for stunning visuals and fast development cycles. Xamarin, using C#, and Ionic Framework, which uses web technologies like HTML, CSS, and JavaScript, are also solid choices depending on your team's experience and project needs. Just remember that while these tools help a lot, testing across both platforms is key to ensuring everything works perfectly for your users. Okay, so when it comes to building mobile apps, we have two main options, native apps and PWA. Native apps are built specifically for iOS or Android, which means they're designed to take full advantage of the device's hardware and software. You install them from the App Store or Google Play. PWAs, on the other hand, are web applications that look and feel like native apps. You just type in a URL to access them. They don't require installation, which is super convenient. A big advantage of PWA is they can work offline thanks to something called service workers, and updates happen automatically without needing an App Store update. Let's look at some key differences like platform support, how they are installed, and how they handle offline functionality. Okay, let's talk about mobile edge computing. It's a really important concept for mobile developers. Basically, instead of sending everything to the cloud, we're moving some of the processing closer to where the user is. Think of it like having a mini server right on your phone or nearby device. This drastically cuts down on lag and saves bandwidth because less data has to travel back and forth. It's especially useful for things like augmented reality or self-driving cars that need super fast responses. So, MEC reduces latency, lowers costs, and makes apps more reliable. It's a game changer. Okay, let's talk about augmented reality. Specifically how ARKit and ARCore are changing mobile development. These frameworks allow us to blend digital content with the real world. Think placing virtual objects on your desk or seeing a 3D model floating in your living room. They use things like plane detection to find surfaces you can place things on, and object tracking to recognize specific items so the virtual elements stay attached. ARKit is primarily for iOS, known for its ease of use, while ARCore is great because it works across a wide range of Android devices. If you want to dive deeper, I'll leave some links in the description. Okay, let's talk about App Store Optimization, or ASO. Think of it as how you make sure people can find your app when they're browsing the app stores. It's not just about having a great app, it's about making sure potential users know it exists. There are really 6 key areas to focus on. First, keyword research, figuring out what words people are actually using to search for apps like yours. Then, you need to optimize your title and subtitle with those keywords. Don't stuff them in the air, but definitely include the most important ones. Next up is your app description. Make it compelling and highlight the best features, focusing on the first few lines. Of course, good screenshots and a video preview are super important too. They give users a visual feel for what you're offering. And don't forget your app icon. It's often the first thing people see. ASO is constantly evolving, so it's important to track how things are going and make adjustments along the way. Okay, so let's talk about what's new and exciting in mobile development. We're seeing some really big shifts happening. First up is 5G. It means faster download speeds and smoother streaming, which opens the door to a lot of cool augmented reality and virtual reality experiences. Then, AI is becoming increasingly integrated into our apps, making them more intelligent and intuitive. Things like personalized recommendations are getting smarter by the day. And finally, mobile devices are taking on a bigger role in controlling all sorts of things from your smart thermostat to industrial sensors. It's a huge growth area for developers. Okay, let's talk about scalability. It's crucial for any app that starts to gain traction. As more people start using your mobile app, things can get tricky really fast. We see a lot of challenges pop up around network bandwidth, meaning the amount of data being transferred between the phone and the server. If everyone is trying to download at once, it slows everything down. Then you've got database bottlenecks. When the database gets overloaded with requests, the app can start to feel sluggish. Server capacity becomes a problem too. Your existing servers might not be able to handle all those users hitting them simultaneously. And finally, if you're not smart about caching data, you'll be constantly asking the server for things that could have been stored locally on the phone, again causing delays. Overcoming these issues often means moving towards more sophisticated solutions and careful planning from the start. Thank you for watching.